So let's talk a bit about expansion of linear expressions. Now, expansion of linear expressions really is based on two ideas. The first idea that I'm going to write out in my old star notation first is that x plus y star, so remember star represents negative numbers, is equal to x star plus y star, which is equal to x star minus y. Now, if you're uncomfortable with this, please go back and check the work that we did earlier with negative numbers. And if you work through all the ideas, hopefully it should all be clear to you. Now, I can write it in more conventional language, and the way people write it is minus x plus y is equal to minus x plus minus y, which is equal to minus x minus y. Now, please note that you have to think about these things carefully, because all these things can be integers and they can also be rationals. So that means you have to deal with positive and negative numbers and positive and negative fractions. You have to deal with all of them to make sure that all of this holds true. Similarly, there's another expression, which is the expression of x minus y star, and x minus y star is equal to x star, so you have to be careful, x star plus, so this I will rewrite as x star minus y star, which turns out to be exactly equal to x star plus y. And in usual language, if I were to write it, this would be minus x minus y, which is equal to minus x minus y, which would be equal to minus x plus y. And again, I will repeat the same ideas, that this also has to be thought through carefully, but you have the ability to do that because we have developed negative numbers carefully. You have to think about integers and rationals at the same time, both positive and negative, to make sure that everything works out to be okay. So that's one idea which is important. I want to underline this equation and this because this is the usual way of writing these expressions, and that's what we will use over here. The second idea is the distributive law. So what do I mean by the distributive law? So now we've already talked about the distributive law and their various examples that you have seen. And in algebra, distributive law is really an assumption, but please note that it is a very valid assumption. That, for example, just think about it. You work through the distributive law for whole numbers and for fractions. But let's even think of negative fractions. So let's imagine a government which is going to incentivize. So what it's going to do is that it's going to charge a tax of. So this is why you're going to go in debt of 1/100th of whatever profit you're going to make. So it's minus 1/100th x that you're going to go debt in. Now, please note the government is very nice, because if it's also saying that if you actually lose money, so for example, it's supporting businesses, because if x is positive, you're going to pay money to the government. But if x is negative, the government is actually going to pay you a small amount of money so that you can support your loss-making business and make it turn around and make it successful. So now let's say what happens is that you have your business, and there are, so in one venture, what you did was you made half a rupee, but in the other venture that you did, you actually lost 3/4 of a rupee, right? So now there are two ways that you can think about this problem. One is that for every action that you take, so you can, first of all, there are two ways to calculate it. One way to calculate is that you first calculate maybe individually, you will calculate minus 100 multiplied by a half, and then you will add minus 100 times minus 3/4, and that's what you owe to the government. Now, it could be that whether it's a positive or a negative number is a different story. And a different way of calculating it would be that you would first calculate the sum of a half minus a 3/4, which is minus a fourth, and then you would calculate minus 100, minus 1 over 100. So you would calculate minus 1 over 100 times minus a fourth. So you could do it either way. Now, please note, I mean, if you think about it conceptually, they have to lead to the same answer. That's essentially the distributive law. They have to be equal to each other. So you can think about the distributive law in various and build up various stories for it. And what you will end up convincing yourself is that the distributive law is true, and the distributive law can be written in a very general form, which is of the form A multiplied by B plus C is of the form A B plus A C. It is also true that if you want to write it as A multiplied by, it doesn't matter, B minus C is equal to AB minus AC, and we had our previous equations that we wrote down earlier, which was, for example, minus x plus y was equal to minus x minus y, and minus x minus y was equal to minus x plus y. So all of these things should be fairly obvious to you, and all our expansions are going to be based on this idea. So now, given these four equations, let's see what we can do to do some simple expansions. So let's say you have an expansion, a linear expansion like minus 3 multiplied by minus x plus 2y. So now we'll just use the law that A multiplied by B plus C is going to be of the form A multiplied by B plus A multiplied by C, which would be multiplied by 2y. And that will be, now you know, minus 3 into minus x is going to be just equal to 3x, and minus 3 into 2y is going to be minus 6y. So you'll get the answer 3x minus 6y. And if you want to expand a number like let's say you want to expand something like minus 3 multiplied by 2x plus 3y, then what you will find is you're really doing minus 3 multiplied by 2x plus minus 3 multiplied by 3y, and then you'll again do minus 3 times 2x, which is minus 6x, and minus 3 multiplied by minus 3, which is minus 9y. So that's what the answer will be. So this is all essentially, I want to repeat, this is all a function of two things. And the first thing is the distributive law, and the second thing is these inequalities. So if we do, for example, even a more complex problem, like maybe an example like 5y minus 2 multiplied by 3z minus 2 y plus 3z. So let's look at what's going to happen over here. So now first we have to use our laws. Remember, first we have to get rid of the brackets, the parentheses. So first we want to expand this out, and this is just, we're going to use this idea. It's just going to be 2 multiplied by y, which is going to be equal to 2y, and then you want to add 2 multiplied by 3z, so you're going to get 6z, and there's a subtraction symbol out there. There's a 3z here, and I'm going to put square brackets here, and this is 2, and there's a minus, and there's a 5y. So now, then the next line that we're going to use is, and remember there are parentheses here because 2y plus 6z was in the parentheses. So now I'm going to use the inequality, which was, so now the next one is by using the inequality, I'll say this is the same as, so I should write down these equalities. So this is the same as 5y minus 2, and I'm going to just continue writing 3z. Now I'm going to use the inequality over here, and this is going to be minus x minus a plus b will turn out to be equal to minus a, which is going to be minus 2y, and then I'm going to get minus 6z. And now I'm going to take the like terms, 3z minus 6z. That's going to lead to, so these two would be the like terms, 3z and minus 6z will give me minus 3z. So the next equality is going to be 5y minus 2, and I'm going to get minus 3z and minus 2y over here. And now I'm going to use again the distributive law, and the distributive law will help me get to 5y, and minus 2 multiplied by minus 3z is going to give me plus 6z, and minus 2 multiplied by minus 2y will give me plus 4y, so that's going to be 4y, and then I'm going to collect the like terms, which will be 9y plus 6z, and that will be the answer. So you can see that you can take some very complex problems, and by just using the 4 things that we learned, you can just work through examples and get down and get the answer out. Thank you.